Hey there everyone, welcome to Lesson 6 of Theme 3 GCSE Geography. So what we're going to start today is a breakdown of 3 lessons looking at earthquakes, volcanic eruptions and tsunamis. So we're looking at the actual hazards associated with the plate boundaries that we've been breaking down so far. We're going to start with earthquakes. Oh, thanks for that. We're going to start with earthquakes. We're going to use the Haiti earthquake as a case study to look in more depth at how these tectonic hazards impact people. So we're going to activate prior knowledge first about what actually causes an earthquake. We're then going to apply this understanding to the real life example of the Haiti earthquake that happened in 2010. And then we're going to identify why low-income countries such as Haiti are impacted differently to high-income countries, such as the USA, for example, the West Coast, California. That San Andreas fault creates a lot of earthquakes, but the impacts are very different in rich countries versus poor countries, and the exam board love a high marking question like that. So pause the video here a moment, go ahead, write down the title, and we'll get started. Okay, so first up, let's activate some prior knowledge on the different types of plate boundary and how they might create an earthquake. So we've got a destructive boundary here. Oceanic crust is colliding with continental crust. The oceanic crust is subducted down into the mantle where it melts. So yes, it will create volcanic eruptions. How does this plate boundary create earthquakes? This is a constructive boundary. The plates are moving away from each other. In this illustrated example, it's 2 pieces of oceanic crust, 2 pieces of oceanic plate. There are some limited examples where this happens underneath the land, like the African Rift Valley. But the majority of these are happening on the seabed. Would these create earthquakes? And if so, how? Now this one is new, and the reason we're covering it is this is how the Haiti earthquake was caused. This is called a conservative plate boundary. Now you did touch on these in year 9. Destructive is so called because it destroys crust. Constructive is so called because it creates crust. Conservative is so called because it conserves. It keeps crust the same. It doesn't destroy or create crust. Because what's actually happening here with the plates is they are sliding past each other, in this example, in opposite directions. You can see the 2 arrows here. And that is also sometimes known as a strike-slip fault. So bearing in mind that earthquakes are caused by friction, building up of pressure, how might this type of boundary create an earthquake? So pause the video here a moment and just have a little think. I don't want you to necessarily write anything down, but how might earthquakes happen at each of these 3 boundaries? Okay, let's break it down a little bit. So with the destructive boundary, these are some of the most powerful earthquakes that you can get, because what's happening is where the oceanic crust is subducting beneath the continental crust, the friction is so great that it actually drags the edge of the continental crust down a little bit. This is what creates our ocean trenches as well. That pressure builds up to such high levels that because the pressure builds up so high, when it is released by the movement of that plate sort of pinging back upwards on the sea floor, the edge kind of thrusts back upwards. The pressure is so great that the power released by the earthquake is much greater. So destructive boundaries tend to cause pretty big earthquakes. Constructive boundaries, on the other hand, these don't really cause earthquakes in themselves. What you might get here is smaller tremors and smaller earthquakes where the magma is forcing its way up through the gap that's being created by the divergent plates, by the plates pulling apart. So earthquakes aren't a main hazard of constructive boundaries. You may get smaller ones due to the pressure of the rising magma rather than the pressure of the plates themselves acting on each other. So much smaller, lower level earthquakes here. Conservative or strike-slip fault boundaries, these create pretty massive earthquakes because obviously these slabs, these massive pieces of crust, they're not coated in like non-stick surface in between. So imagine you've got massive slabs of the Earth's crust with continents on top of them trying to slide past each other. This is huge chunks of rock. It's going to get stuck. But the convection currents in the mantle underneath that are moving the plates are continuing to churn and continuing to move. So it's still trying to pull this plate this way, and it's still trying to pull this plate this way. But the plates are stuck. The continuing movement of the magma in the convection current underneath the stuck plates builds pressure higher and higher and higher until eventually those plates will shift in opposite directions all in one go. So this creates pretty massive earthquakes. You're looking at magnitude 5 or higher here, really, most of the time. An example of this in real life is the San Andreas Fault. So it tries to just sort of bump and coast past each other most of the time. In fact, the San Andreas Fault is actually two plates moving in the same direction but at different speeds, but it's still an example of a conservative plate boundary. So California, for example, gets about a few minor quakes every day, in fact, 3 or lower on the Richter scale. We'll come to the Richter scale later on, which you wouldn't necessarily feel. Maybe sort of up to 11 sizable quakes. You sort of feel a little bit of shaking every couple of years. About every 100 years or so, you get a massive one of 6 or higher on the Richter scale. So the San Andreas Fault, California, Western USA is a prime example of this, as is the strike-slip fault that an island called Haiti sits on. And that's what we're going to look at today. Before we go any further, there are some key terms that you're going to need. So pause the video here a moment and write these down, please. So the focus is the point underground where the earthquake begins, and the epicenter is the point above the focus where the shaking spreads out at the Earth's surface. So there's your focus, where the actual rip, the break, the movement happens within the crust, and above it is the epicenter where the shaking kind of ripples out in all directions. All right. Seismic waves, conservative, we've just covered. Strike-slip fault, we've just covered. Magnitude is another word for size or power. And the Richter scale, it's named after the guy that came up with the scale. His surname was Richter, so always spell it with a capital R because it is a name. It's a logarithmic scale. Now what that means is each step on the scale, it goes up to 10, is to the power of 10. It's 10 times more powerful than the step before. So if you ever get a little numeracy question in an exam, it might say that a magnitude 3 earthquake has struck wherever in the world. How many times more powerful would a magnitude 7 earthquake be? Show your workings. Basically, for each step, so 3 to 4, 4 to 5, 5 to 6, 6 to 7, you're adding a 0 on the end. It's 10 times more powerful than the stage before, and that's what we call logarithmic. So pause the video here a moment and get down these key terms, please. All right, now, usually if we were doing this in school together, I would give you a nice big A3 case study sheet that looks just like this. Now, if you've got a printer at home and you want to print this out, it might be a little bit small on A4 actually. So what I would probably suggest is don't print it out at all. Just put these subheadings in your book and write them down under subheadings rather than into the boxes on this sheet. Again, if we were in school together, I've actually got a documentary that we would watch. I've got it on a DVD. It's not available online anymore because Channel 4 don't have it on catch up and it's copyrighted. So this lesson is going to be research based, and I would like you to essentially put these subheadings in your book and then use the internet to try and find examples and answers to go under each subheading. So before you go off and do that, let me just walk you through what to do with each subheading in case you get a bit stuck. So with the location, what I'd like you to do is try and draw a sketch map as best you can to show the shape of the island, and then describe the location in here. Describe means say what you see, and with a location, start big and work your way in. What ocean does it sit in? What continent is it part of? Stuff like that. And any other background information you can find. So what's the name of the capital city? How many people live there? Because this earthquake happened only just outside the capital city. Now, to give you a little idea of the location that we're talking about, let me come out of here a second because I have loaded Google Earth. So here's us, obviously. Now, if you come westwards across the Atlantic Ocean, that was embarrassing, across the Atlantic over to, so there's North America, South America. This is the Caribbean, Central American area. So Haiti, if we come in a little bit. All right. So you can see this island here. And there's a little boundary running down the middle there. The western half of that island is Haiti. The eastern half is the Dominican Republic, very popular Caribbean holiday destination. And if I zoom in a little bit further, you can see going along here, underneath the island, and then out here and here is a plate boundary. Haiti sits right on the boundary between, I think, the North American and Caribbean plates. Double check that in your research. The North American plate is trying to go one way, the Caribbean plate is trying to go the other. And they're ripping the island apart, essentially, along a strike-slip fault, a conservative plate boundary. Now, Haiti is the poorest country in the Western Hemisphere, in the whole western half of the world. Most people here are surviving on, I want to say, 66 US dollars GDP. GDP is the average earnings per person per month in the country. So very low income, super poor country. All right, now we're going to come back to that in terms of why it's so vulnerable to the impact of earthquakes. So that's just to give you an idea of the location, and it's the outline of this island with the country border between Haiti and Dominican Republic. Label Haiti and the Dominican Republic, label the Caribbean Sea. Port-au-Prince is the capital city. It's right there, just underneath where it says Haiti. Okay. So in your sketch map, I'd like to see the outline of the island, label these two countries, label the capital city, label the sea. All right. From current slide. With the effects, try to find out, obviously, how many people were killed and things like that, but also try to find out information about buildings that were destroyed. Something happened to the docks as well. It's called liquefaction. So when the ground shakes violently enough, it breaks the bonds between the particles in the rock and the mud and the soil. And what happens is that solid rock and earth starts to behave more like a liquid, liquefaction. So anything that's built on the land that gets liquefied is going to sink and it's going to slump. Now, Haiti is an island. So the docks were destroyed, which means that not only people can't evacuate and get off the island, but then aid and help can't get in, can't get onto the island. So it basically cut off the island from help from the outside world, because as an LIC as well, they don't have much rescue equipment, very poor hospital and healthcare systems. So what I mean by color code primary and secondary effects, so once you've bullet pointed maybe 10 or so main effects on people, the economy, the infrastructure, roads, electricity, power cuts, and stuff like that. Once you've bullet pointed around 10 main impacts, see if you can color code primary and secondary effects. Now, primary are things that happen straight away. So initial death count, initial death toll. Secondary effects are things that happen over the coming days and weeks. So due to lack of healthcare, due to lack of rescue equipment, that death toll may have risen. Help and aid can't get onto the island. That would be a secondary effect, because that's going to impact the recovery over the coming days and weeks. This one might be a little bit more tricky, so don't stress yourselves out too much with that one if you find you can't do it. The main aim with this box is to get an overview of the main impacts, the main effects of the earthquake. I'd like you to explain how it was caused. So go back and listen to how I explained how a strike-slip fault works. That's basically what's happened here. And you'll be able to find out more about that on the internet too. Write down a little bit about the Richter scale. So I've got a visual representation here of how it sort of works. And from 0 to 2, from 2 to 3, from 3 to 4, 4 to 5, each step on the scale, roughly what physical manifestation this would take and level of damage it would cause. So in here, who invented the scale, when was it invented, how do we use it, and explain a little bit about what we mean by logarithmic, that each stage is 10 times more powerful than the one before. Now then, these bottom two boxes, okay, response and future hazard reduction. I've created an extra information sheet here for you about response. Like we said, Haiti is such a poor country, they had to rely on global intervention. There was a huge outpouring of aid. Yes, they had some response within their country. They tried to do their best, but there were countries all over the world then that sent humanitarian aid. Humanitarian aid is humans. They sent doctors, they sent medical supplies, they sent food parcels and clean water. That's humanitarian aid. They sent monetary intervention as well, obviously giving money to the government so they could rebuild and construct stronger than before. There's something as well about future preparation. It's called the 3 Ps. We're going to come on to this later. Predict, prepare, and protect. LICs often don't have these strategies in place because to protect means to stop buildings from falling on people. And that takes money. earthquake-proof technologies. LICs like Haiti don't have it. To predict, you need scientific equipment, like a seismograph, like a tilt meter. These measure ground shaking and levels of pressure. The equipment costs money, and you need educated people to monitor it. LICs don't have those two things. Predict, protect, prepare is the final one. To prepare means to know what to do in the event of an earthquake. Well, lack of education, lack of communication, LICs often aren't prepared. So if you can't predict when it's going to happen, you can't protect yourself from buildings falling on you, and you're not prepared in knowing what to do when it happens, the death toll is going to be higher, isn't it? So there are some affordable ways of implementing the 3 Ps in Haiti that could reduce the death toll from future earthquakes. So use this to help you fill in this. Bullet points is absolutely fine. And then this last box here, you probably write more than I've actually allowed space for here. Vulnerability, link back to last lesson. Okay, why are people more likely to die, and why is the impact of an earthquake going to be greater in a country like Haiti than it would, for example, in a country like America if an earthquake struck the west coast of California? So you've got several things here. Haiti is an LIC. People are living in poorly constructed homes. The city is very densely populated, Port-au-Prince, and the earthquake happened only just outside that capital city. Haiti is also an island, which makes it very difficult to recover and rescue and get help or evacuate. So there's several factors from the spider diagram that we made last lesson that would apply to explaining why Haiti would be hit much harder by exactly the same size of earthquake as if that earthquake had happened on the west coast of America, which is obviously a HIC. So, pause the video here a moment, subheadings in your book, use the internet, my previous verbal explanations, and this slide to help you write as much as you can under these subheadings into your book. You're welcome to make your own version of this diagram. Do not worry about trying to make your own version of this diagram. Okay? Right then, off you go. Okay, so I've pulled together some of the key points that you might have come across. Now, bear in mind, I've got these from the documentary, which you weren't able to access, so you might have found slightly different numbers on the internet, depending on the websites that you use, and that's always important to bear in mind when doing internet research, is you might find slightly different facts and figures based on the sources that you're looking at. So, social impacts on people. 3 million people were affected. That's the same number of people as we've got in the whole of Wales. About 300,000 injured, 1.3 million made homeless, and they ended up living in temporary accommodation. They were scrambling and rummaging for anything they could find in the rubble. And basically, even 10 years or so after, there's a lot of people in Haiti still living in temporary shacks, almost like giant shanty towns, because they don't have the money to rebuild. Several hospitals collapsed, the prison was damaged, and inmates escaped. 2 million live as squatters in shanty towns after being made homeless by the quake. So that's 2/3 of the people that were affected. And like I said, a lot of those people are still in that state now. Given this happened way back in 2010, January 2010, we're looking 11 years almost to the date. I think it was the 12th of January. Yeah, 11 years almost to the day of me making this video. And there's a lot of those people still living in temporary accommodation because Haiti doesn't have the money to rebuild and recover. 2 months after the quake, the rainy season started. This is a tropical country. It's in the Caribbean. You've got 500,000 people still living in shanty towns. And that's going to mean that with that rainfall, obviously shanty towns don't have clean running water or sewage systems. So you're going to get diseases spreading easily like cholera. The risk of landslides as well is going to increase. So there were a lot of secondary deaths from that. And that's what you've always got to consider with a tectonic hazard is, okay, it will kill people immediately, but then the aftermath linked to the location. So this is a tropical climate, you're going to get diseases. If this earthquake had happened in the Himalayas, countries like Pakistan, people die from exposure. When the winter comes around, they literally freeze to death because, again, it's a poor country, Pakistan. You're going to have people living in temporary homes after theirs were destroyed, and the country doesn't have the money to recover. So you'll get secondary deaths. In terms of economic impact, the money lost and businesses and things impacted, 30,000 businesses Their buildings were directly affected or destroyed. Damage to the main clothing industry. A fifth of all the jobs on the island have been lost due to the quake. And of course, if the docks are destroyed, your importing and exporting is going to be heavily impacted. And that's one of your main ways of making money because you're an island. Why was Haiti so vulnerable? GDP, that's how much each person earns. I said $66 per month, so I was close. The average person in Haiti earns $660 per annum. Per annum means per year. In pounds, that's probably about £500 a year. A year. You're living on about 40 quid a month. How can people live like that? There's no way you're going to have the money to make sure your home was earthquake proof. There's no way you're going to have the money to buy earthquake preparation kit. Just not going to have these things. Out of 182 countries, they're ranked 149th for development. So they're very, very poor, very much less developed than a lot of other countries in the world. Very few earthquake-resistant buildings. It costs money. There were few resources to treat injured people and rescue injured people. More people are going to die. The government is really disorganized as well. This is very common with LICs. So they had to hand over a lot of the aid effort. They tried their best to recover and rebuild and restructure themselves, but they had to hand a lot of it over to American authorities because what was actually happening is the infrastructure couldn't cope. All this global aid and global help was beginning to come in, and the government just couldn't distribute it properly, and were making a right mess of things. Overpopulation. We've looked at this in our factors affecting vulnerability. People were so densely packed into Port-au-Prince, right next to the epicenter of the earthquake, and that meant that obviously more people are going to be affected in a small area. You've got lots of ad hoc buildings that aren't built properly. They're just thrown up. So when an earthquake happens, everything falls down on top of each other. The response, much of the early rescue work was done by the Haitians and by the teams from the Dominican Republic next door. They were the first country to respond. And within 24 hours, a medical team from Iceland had landed. 50-strong Chinese intervention team, Qatar and Israel, the UK, America. It was a global response. This hit the news big time. You guys probably won't really remember it, but it was absolutely everywhere. So this gives you a little bit more of an overview. If you've missed any of these points and you've got space, pop a couple of them under your subheadings where it applies. Okay, and you should now essentially basically have created lesson 65. You should basically have created underneath the subheadings in your book a really in-depth case study of the where, the why, the how, the response, the vulnerability, basically an overview of an earthquake in an LIC, how it happens, the impact that it has, and why the impact is so much greater in an LIC than it would be in an HIC. Okay, so that's lesson 6. I obviously clearly haven't deleted the 5 or spaced it properly. This should say lesson 6. Well done. So I'll see you soon for lesson 7, and we'll start looking next at volcanic eruptions and tsunami hazards.